We finally touched the edge of the sun's domain. Welcome to a journey beyond the known world, where humanity touches the vast, silent void of the infinite interstellar space. Two lonely robotic ambassadors have traveled further than any object made by human hands, entering a realm of total mystery. For decades, we believed we understood the boundaries of our home, but the edge of the solar system held surprises. This protective bubble is called the heliosphere, a vast magnetic shield created by our sun to defend against galactic radiation. The sun constantly fires a stream of charged particles known as solar wind, inflating this bubble against the interstellar medium. Our story began back in 1977, when Voyager 1 and Voyager 2 were launched on a grand tour. They captured breathtaking images of gas giants, revealing storms and moons, before drifting silently into the cold, dark, unknown. After completing their primary missions, they did not stop. Instead, they continued outward, aiming for the edge of our star. Scientists waited patiently for decades, wondering when these brave explorers would finally cross the threshold known as the Heliopause. The Heliopause is the theoretical boundary where the sun's magnetic influence ends and the vast interstellar space truly begins. For years, astronomers debated what this boundary would look like, predicting a gradual and chaotic transition zone of turbulence. They expected a soft, messy edge where solar winds would slowly fade away while mixing with the galactic environment. However, reality proved to be far more shocking than any theoretical model had ever predicted for this historic crossing. In August 2012, Voyager 1 finally pierced through the veil, becoming the first human object to enter interstellar space. The data sent back was unmistakable. The solar wind particles it had detected for 35 years suddenly vanished completely. Simultaneously, the detection of high-energy cosmic rays from the galaxy spiked dramatically, confirming a complete change in environment. Instead of a gradual fade, the boundary was sharp and distinct, like stepping from a warm room into a blizzard. This discovery stunned researchers, revealing that the transition between our sun's domain and the galaxy is surprisingly thin and rigid. 6 years later, Voyager 2 confirmed this phenomenon from a completely different direction, proving it was not a localized anomaly. Both spacecraft experienced the same sharp drop in solar particles and the same sudden increase in galactic cosmic radiation. This boundary acts as a crucial shield, blocking nearly 70% of the dangerous cosmic rays that bombard our system. Without this protective heliosphere, life on Earth would be subjected to much higher levels of lethal radiation from deep space. The clash between the solar wind and the interstellar medium creates a dynamic wall that breathes with the sun's cycle. Another surprise was the density. The space outside the bubble is much denser with plasma than scientists had originally calculated. The probes detected that the interstellar medium exerts significant pressure, compressing our sun's magnetic bubble inward more than expected. This pressure suggests our solar system is moving through a particularly cloudy and dense region of the Milky Way galaxy. Despite the harsh environment, the Voyagers continue to send back faint whispers of data across billions of miles of void. Every bit of data they transmit rewrites our textbooks, offering the first direct measurements of the galaxy's true nature. They found that the magnetic fields in interstellar space are smoother and stronger, guiding charged particles in organized highways. Understanding this magnetic alignment helps astronomers predict how other star systems interact with their own local galactic environments. But why does this matter to us? Because humanity plans to leave Earth and travel to the Moon and Mars. Once astronauts leave Earth's magnetic field, they are exposed to the same cosmic radiation that the Voyagers are measuring. The data from Voyager helps scientists build accurate models to predict radiation exposure for future deep space human missions. Knowing the intensity of galactic cosmic rays allows engineers to design better shielding to protect our explorers from cancer. Even on the Moon, which lacks an atmosphere, understanding the fluctuations of the heliosphere is vital for long-term habitation. When the sun is less active, the heliosphere shrinks, allowing more dangerous galactic radiation to penetrate closer to Earth. Conversely, a more active sun inflates the shield, providing better protection for astronauts traveling through the inner solar system. Voyager has given us the baseline truth to calibrate these cycles, making space weather forecasting much more accurate and reliable. These discoveries have also ignited hope for a new mission specifically designed to go faster and further than Voyager. Scientists are proposing an interstellar probe that could reach the Heliopause in 15 years, not 35 like Voyager. Equipped with modern sensors, this new explorer could analyze the dust and magnetic fields of the galaxy with unprecedented precision. It could even explore the Oort cloud, the distant icy shell that marks the gravitational boundary of our solar system. But for now, Voyager 1 and 2 remain our only eyes and ears in the darkness beyond the solar wind. Their nuclear batteries are dying. Soon, they will fall silent, drifting as ghost ships carrying a message from humanity. They carry the golden record, a time capsule of sounds and images, waiting for an alien civilization to find them. Long after Earth is gone, these machines will continue to orbit the center of the Milky Way, practically forever. Their journey through the Heliopause reminds us that we are capable of touching the infinite, despite our small, fragile nature. The data they collected at the edge of our world will fuel scientific discoveries for generations of astronomers to come. We have learned that our home is a protected island in a vast, energetic ocean that is wilder than expected. As we prepare to send humans to Mars, we owe a debt of gratitude to these two vintage robotic pioneers. They prove that with curiosity and determination, we can overcome the limitations of technology and time to explore the unknown. From out there, Earth is just a pale blue dot, but it is the only home we have ever known. The Heliopause is not just a physical barrier, it is a symbol of humanity's relentless drive to push beyond boundaries. As Voyager 1 fades into the cosmic night, it leaves behind a path for us to follow in the future. The silence of the space between stars is now broken by our knowledge, illuminating the dark corners of our galaxy. Every sunrise on Earth is shielded by the same magnetic bubble that Voyager crossed, connecting our daily lives to deep space. Perhaps one day, a child watching this video will be on the first ship to physically cross that same boundary. Until then, we keep listening, keep watching, and keep dreaming of what lies beyond the protective embrace of our sun. The story of the Heliopause is far from over. It is merely the first chapter in our interstellar history book. We celebrate the engineering marvel that survived 12,000 days of space travel to deliver these precious secrets to us. Our sun is just one star among billions, but it is the only one whose bubble we have ever mapped. From the first satellite to the interstellar crossing, every step takes us closer to understanding our place in the universe. The universe is vast and filled with secrets, and we have only just scratched the surface of what is possible. Discovery is not a destination. It is a continuous journey that requires courage, intelligence, and an unyielding spirit of adventure. Thank you, Voyager, for showing us the edge of our world and opening the door to the rest of creation. If you enjoyed this deep dive into the mysteries of the Heliopause, please take a moment to support our channel. Don't forget to hit the like button and subscribe to Universe Secrets for more amazing stories from the cosmos.